Welcome. Uh, so we are going to be presenting today on what's a data lake and what does it mean for my open source ClickHouse stack. Before we get started with this presentation, I'd like to just give you a little bit of housekeeping information. This talk is being recorded, as you just heard. We will provide both a copy of the recording or a link to the recording as well as the slides. After this talk, you'll get it most likely within a few hours of the talk being completed. Also, this talk has a number of demos, or well, a couple of them with um, based on a reference implementation of Iceberg using Docker Compose. There is a link to that at the end of the slide, so you can also find the code that we're running as well if you want to try it yourself. So with that, let's go ahead and dive in and do some introductions. So my name is Robert Hodges. I'm CEO of Altinity, and I've been working on databases for about 40 years. So today I'll be your guide on this. I do have my friend and colleague Alexander Zaitsev. He's CTO of Altinity. He's also here. He'll be around to help answer questions, and also may chip in for some of the stuff that we'll be talking about today. This talk is based on our experience in Altinity engineering. We have about 50 people in the company spread out worldwide. Most of us are engineers, have positive experience with databases, particularly, of course, with ClickHouse and increasingly with data lakes. And that experience is something we'd like to share with you today. Just a little bit more about Altinity. Many of you who are on this call may know us because we're authors of the Kubernetes operator for ClickHouse, also called the ClickHouse operator in GitHub. We do the Altinity community plugin for Grafana that's got close to 20 million downloads. We do the ClickHouse backup project, and we do a bunch of work on ClickHouse itself. We have what are called Altinity stable builds. We've done hundreds of PRs on ClickHouse over the years, so we're very uh, interested in and invested in this technology. So that's the basis for some of the stuff that we're providing today. What I want to do in this talk is just start with the basics. What is a data lake? And as we dig into that, one of the first questions we want to ask is, well, why? Why is this important? And this graph that I'm showing gives you an illustration of the increases in data size over the last 5 years or so. Altinity's been in the business working on ClickHouse since 2017, and we've seen this enormous, like everybody else, we've seen this enormous growth in the amount of data that's being managed in real-time data warehouses. So this started back in 2019. When we would get people coming on board, they would often have, say, 100 gigs of data, not uncommon. But that has rapidly increased to data sets where we're dealing with many petabytes, particularly as we deal with large observability data sets. This increase in growth that's on the order of 10x per year in some cases is putting pressure on data warehouses because it's very difficult to stuff all this data into data warehouses and first of all manage it, but the other thing is it's not particularly accessible to users. So data lakes have emerged as an answer to this problem of being able to store very large amounts of data cheaply. And so what I'd like to discuss, as sort of the next part is like what actually is a data lake and how did they evolve? One way to understand data lakes is to think about what happens inside a data warehouse today. So if you use ClickHouse, ClickHouse is a query engine and your applications connect to the ClickHouse server. ClickHouse, of course, manages storage, but the way that that storage works and the access methods are completely hidden to you. That's actually a benefit in most cases because you really don't want to know. Your applications will connect. You'll run your queries. ClickHouse will take care of the rest. What's going on under the cover? Well, ClickHouse has a notion of tables. So getting your data organized in a tabular form, having a schema for those tables, having a format for the files that are used to store the data in the tables, being able to break the data into parts, being able to hold statistics on those tables like min-max indexes or primary key indexes, have some understanding of transactions like not showing people parts of partially written blocks. And then time travel, which is a feature that ClickHouse doesn't really have, but is present in many other data warehouses. Well, what a data lake does is it takes that storage, which is previously hidden, and makes it accessible to other applications using APIs that everybody can read and write to. So, uh, so you can think of your storage as just being pulled out, and the query engines can still get to it, and the applications can still attach to you can still connect to the query engines, but other applications can connect to it as well. And what this does is not only do we have the key thing here is this basically allows a wide range of applications to work on a single copy of data. And so the key in the data warehouses today is they offer these same capabilities that the data warehouses were providing internally, but everybody can get at them. Incidentally, this type of organization where, for example, you have transactions or you have things like schema is often called a data lakehouse. I'm going to say data lakes today. Data lakehouse is really kind of a marketing term that was developed by the Databricks folks. There's a seminal paper that they wrote in 2021. It's in the references section. Uh, and it describes it, and basically it was describing combining the ability to store things cheaply, but also to have these controls that we expect when we're managing large amounts of data in a data warehouse. So from here on out, we're going to talk about data lakes. That's what we mean. So data lakes are actually pervasive. They're not greatly used yet in data warehouses, but over the years, a bunch of other applications have begun to use them very heavily. They include model training, they include data science, they include large batch operations. For example, Spark jobs where they're manipulating very large amounts of data. They are building on these data lakes, which have open table formats. So things like Iceberg, Delta Lake, and Hudi. We're going to dig mostly into Iceberg here. They have the file formats, Parquet or ORC, and then they're based on object storage, typically S3 compatible object storage. These solutions offer global access, as we've already said. There's another important part to them, which is they run in user accounts. So these data sets are so large that people typically don't want to push them into some cloud service that somebody else owns, like Snowflake, because one, they lose control, and two, it's really expensive. So this is already working and allowing multiple applications to work off a single copy of data. Let's dig in a little bit and look at the actual plumbing. So, and at this point, we're going to turn and focus fully on Iceberg uh, for a variety of reasons, but the main one being that Iceberg looks like kind of a winner in this race. There's a number of different table formats that you can use. They include Hudi, they include Delta Lake, they include Pymon. Iceberg, for better or worse, is turning out to be probably the most popular one. So when you build a data lake and on Iceberg, what do you actually have? Well, you have the S3 compatible object storage. So it can work on, you can also work with object storage that doesn't use the S3 API, but that's the most common. You have data, which is most commonly stored in Parquet files, although of course you can support other things, but Parquet is another format that is widely used. And that holds the actual information that you're going to be selecting from. Parquet, you can think of it if you're a ClickHouse person, it is an analog to the merge tree table format or file format, where it stores data in columns, it compresses it, it has indexes built in, and metadata and schema. So it does all the things that merge tree does. It's an open format that anybody can read or write. And then you have metadata. So you've got files. The metadata in Iceberg tells where basically creates sort of manages the tables. So what is the table? What's its name? How's it partitioned? Where are the files located from it? So that's all stored in the metadata. And then because you don't necessarily want to go out and have to manipulate these metadata files yourself, there's what's called a catalog, and a catalog holds the list of metadata files, their location, where they're located, and you can, instead of having to go read the metadata files directly, you can just connect to to the catalog and get the information all from one place. And so with these parts, the S3 compatible object storage, the Parquet file format, the Iceberg metadata files, and then a catalog to keep track of them, you have all the parts that's necessary to allow a Python data science application to connect to your data lake. So let's look at exactly what it does. Well, when this Python data science application spins up, if you're going to go do selects off, or you're maybe building a workbook, you're going to pull some data, you're going to run some graphs on it. How does it actually get to the data? Well, here we see that we have uh, the Python data service science application. It's going to have libraries, and we'll talk about those in just a second. The first thing they're going to do is when we want to go look up a table, we will connect to the catalog service. And we'll say, hey, we want to talk to this particular table, go fetch me the metadata. And so that metadata will get pulled down through the catalog. And then the Python libraries know where the actual files are that they need to go read, and then they will go and read them directly. This is a really important point because unlike using a database like ClickHouse, there's no server between you and the data. The applications go and read it directly, and this is one of the things that allow many people to read the same data because they can all see it and access it. So let's go a little bit further and do a reference implementation. In this particular case, the example I'm using, we're going to use MinIO to provide our S3 storage. We will have our metadata managed by in Iceberg format. We'll have our data in Parquet. We're going to use an Iceberg REST catalog, which provides, this is a feature of the Iceberg specification. It provides a REST catalog that gives us an API that we can call to actually get information about tables. And then finally, because we're in Python, we're going to leverage a number of libraries. The most important one, and the one we start with, is PyIceberg. That is a library that knows how to find and select from Iceberg tables. We're going to use PyArrow. That is a library that knows how to read and write Parquet. And we're going to use Pandas because everybody uses Pandas for data frames, and we need it if we're going to dump data easily and make it visible to users. So these are all the parts of the the application plus the data lake. Let's go and actually look at an example of this. And by the way, since you're looking at this right now, if you have questions as we're going along in this, this talk, I know this is a very popular topic. Please feel free to put them into the Q&A box or the chat, and we'll answer them as we go along. Let's dig in though and run the demo. So make this smaller, and let's go ahead and start. What we're going to do right now is we're actually going to build a table out on this little Iceberg data lake that we've set up, and we're going to put some data into it, and then we're going to prove that we can read it. So for this, we're going to run a script, and let me just show it to you so you can get kind of a sense of what's in this. But here's what a Python application looks like that's talking to a data lake. A lot of code. So here we're connecting to the catalog. You can later on look at this yourself, but we're going through every individual step to connect to the catalog, create a namespace. This is something where tables can live. We're going to list our tables. We're going to have some kind of complicated code to define the schema of a table. We're going to create the table. We're going to put data in it, so on and so forth. This is a very low-level approach to accessing data, and you'll notice there's not a drop of SQL in this. Let's go ahead and run this script. So there it is, Python. So we will run it like this, and off it goes. So it's connecting the catalog, creating the namespace, listening to namespaces, added some data, added some more data. Very, very simple. We're going to add 4 rows. And let's go ahead and run another script where we actually read this. Once again, we can go ahead and the code for reading it is much simpler. Basically, we can load we connect to the catalog, go find the table that we just created, which is called Iceberg Bids, and we're going to do scan the table. So read all the data, put it in a data frame that's run by pandas, and then just print it. So let's just run that. And there you go. We've got 4 rows of data. As it turns out, as you'll see later, it's in 2 partitions because we're partitioning our data by day. So there are the rows. We put it in and we can read it back. So one of the things that's interesting is we can actually go look at this data. We can, for example, fire up the MinIO console and look at it. We're not going to do that today, but we will go ahead and let's get back to our, there we go. Let's get back to our presentation and just have a look at what we've actually done under the covers. So we were connecting to the, as we connected to the catalog, we then went and created the metadata as well as the files that that constitute the data in this table. And so if you go use, go into MinIO and use the console, you would first of all see a bucket called warehouse. You would then under that see a path called data. That's the path, just happens to be the path that I set up for where my Iceberg data is going to live. Under that, you'd see what amount to 2 directories. And bear in mind, of course, in S3, they aren't really directories, but they're just paths. Under metadata, you're going to see all the Iceberg metadata files. It's a mix of Avro and JSON, and we can actually go read them if we want. We can fetch them out, for example. We could directly pull them down using the REST catalog, or we could actually use ClickHouse to read them with S3 commands because they're just S3 files. The actual table data is under the data path, and we would find that there's a further path. This happens to be broken out using kind of what looks like Hive format, and then underneath each of these paths, you would find a single Parquet file. So this data is actually out there, and it is, it's completely accessible to us. And what's neat about it is that if we have a console, we can actually go through and look at the parts. So we're not going to do that today. Let's just talk a little bit more about what data lakes really do. As you adopt this technology, well, one of the things is it's kind of mind expanding and not in a completely good way. There's just a Pandora's box of choices. So we're using Iceberg, but you have other table formats. Iceberg, as I said before, kind of looks like the winner here. For uh, there's the Iceberg REST catalog, but that's not the only kind of catalog. There are many others. Unity, Glue, uh, uh, Nessie, Hive, Metastore. Uh, Beyond that, so you need to pick one. The Iceberg REST catalog is a reference implementation. We're using that because it's simple to use and just pops up quickly. Parquet is a good format. It's not the only one that can be used, but it's a good bet because it's so widely supported by libraries and there's a lot of data already written to it. Uh, you'll have to learn more about languages. We're using PyIceberg, so that's Python, but there are other ways. In fact, if you're using Iceberg, there are certain things in Iceberg that are very difficult to do outside of Java. So because like some of the other implementations, the basic libraries are written in Java, so you sometimes have to go back to those. And then, of course, you have lots of options for storage, and you just take your pick. They all sort of work the same way. A question here that just popped up: does Iceberg provide any data backup or disaster recovery strategy? And the answer to that is an emphatic no. That is something that you as an application user need to put together in an application. So in the same way that a ClickHouse merge tree table doesn't provide backup, built-in backup, that's an application that then sits on top of it. So good question. So let's shift from talking about data lakes and start to bring ClickHouse into the picture. So let's first start by, I think most of you who are here know ClickHouse, but a quick review of the architecture doesn't hurt. ClickHouse is a real-time analytic database. And the way that it works is that you have processors, the ClickHouse servers, They run as separate processes, typically on different VMs. They have their own columnar storage built in. The workhorse storage engine is called Merge Tree, has a bunch of variants, but that's going to be stored on block storage. They can have increasingly good, in fact, very good ability to read and write S3 object storage. So to put files into it, read them back again. It's mostly used today in applications to import data and to export it. ClickHouse also has very powerful caching to make to reads as efficient as possible, uh, and uh, and it has a vectorized parallel query engine, so it's able to spread queries across multiple servers on the network within a single server. It's very, very good at breaking up the data into pieces, basically what amount to arrays, pushing them onto as many cores as it can find on the processor and operating them on them as efficiently as possible. It also uses Zookeeper or Keeper for coordination. That's important, particularly for when we're doing replication, which is built in for certain table types. So this is, excuse me, this is the basic architecture that we're working with. And what's happening right now is it's being extended to work with data lakes, and that's what we're going to talk about next. So how can ClickHouse access the data lake? Well, there's basically three options. One is that you could just go read the parquets directly, skip all this bureaucracy, and go uh, straight into object storage and read them yourself. That has some disadvantages, as we'll see. Another option is you could go straight to the metadata files. So cut out the middleman. Don't trust this uh, catalog service, but go ahead um, and read the data. Uh, read the files directly. ClickHouse can also do that. The third option is to actually go to the catalog uh, and let that tell you what the tables are within Iceberg and access them that way. So we're going to try all three of those and then comment a little bit about which one's most efficient. So how do you actually read the data from S3 storage? Well, you just have to know where the files are. So we had that map of the files a couple slides back. You can use the S3 table function, very powerful function, super fast. There's a clustered format of it called S3 cluster. This is very, very quick to read data. And what you do is you go ahead and just say select star and you give the path. These stars here are wildcards, and this just says, hey, under these directories, you're going to find a bunch of Parquet files. Just read them all and give the data back. And here it is. But you have to know exactly where the data is and in order to read it. And if some of the data, belongs to different versions of files, uh, ClickHouse wouldn't know the difference and would read it anyway. So that's one way to get in. Another way is there's an Iceberg table function, and that allows us to go directly to the Iceberg metadata, and ClickHouse will grab the files. It'll figure out what the table definition looks like. In that case, we will also be able to read the files, and you know, we'll uh, we'll see this data just as we did previously. The third way is to integrate with the REST catalog. This is a little bit more complicated. In this particular case, first of all, we're going to have to set this is an experimental feature. It won't be for long, but we turn it on, and then we can create databases which are based on the contents of the REST catalog. So a database in ClickHouse is really just a thing that knows what tables are where and can get you table metadata. And that's exactly the model we use. So uh, we create this database, and then we're able to start using it as if it were a database inside ClickHouse. This is a very powerful mechanism, because once you've done that, all of your operations that you perform, it's just like you're working on tables inside ClickHouse itself. One small difference, you see these double-barreled names. This is because Iceberg and ClickHouse don't have completely consistent notions of catalog, sort of name spacing of tables. So you get this kind of funky thing where ClickHouse, which does two-level naming of tables, Iceberg can actually have any level, and so we just put the full reference in backticks. But we see the create table, and then we finally get to the point after all this setup, we can just do the selects and it works. So what we're going to do now is there's 3 ways we can go in. Let's go ahead and try them. So let's go back and do another demo. And let's get it's a bit smaller. Okay. So what we're going to do in this case is we're actually going to connect to ClickHouse and try these things out. Let me pull up just a second. Let me pull up my demos. And we're also going to play around with Spark a little bit. So let me just pull this up. We've got data out there. Let's just start with the most basic way of finding it. Let's select the data from S3. So we created, and ClickHouse, we've done no preparation whatsoever in ClickHouse for doing this. We just happen to know where the data is, and we go ahead and do a select count off those Parquet files. And using the S3 table function, let's do a select star. Great, we got our data, so we can see it. Let's go ahead and use the second way of getting in, which is to use the iceberg table function. And here it is. So with the path. By the way, I've taken care of all the authentication under the covers. So in this case, by providing appropriate environmental variables, so you don't see passwords or anything like that. It's all pretty simple. There you go. So we can do the counts. We get the same data. Let's go ahead and list the rows. Once again, you see this. And by the way, the fact that you see 2 blocks, that's because there are actually 2 files under there, and ClickHouse treats them as partitions. So that's the second way. Let's now go ahead and access it through the REST catalog. Now, I've gone ahead and set up the database already, just so this will be a bit quicker. But it was just do show databases. So you see a database called Data Lake, show create database, Data Lake. Let's just look at what it is. There it is. Boom. It's Iceberg. That shows you. In fact, you can see a little bit of the authorization peeking out there, but it has the information about. It knows where the storage is. It has to get things. It knows where the REST catalog is, and it can now go dereference metadata and actually run selects. Let's do a show tables from Data Lake. Should only see one. And sure enough, there it is. Do show create table. And it's going to be Data Lake. And then we have to do our backticks. This, by the way, is going to be fixed. That's on the ClickHouse roadmap. And there it is. It's actually a Data Lake table using the Iceberg table engine, and it just creates this for us automatically. We can see the types here in this data. We can now do selects on it. So let's try to do that. So let's go ahead and do a count, just as we did before. And actually select the data. Oops. Oh, seems like my copy and paste didn't work. There we go. Okay. 3 different ways to read data. So what's the difference? Well, let's do something kind of interesting here. Let's go ahead and change this data. So for that, what we're going to want to do is step over, and ClickHouse can't change data yet out on Iceberg, but Spark can. So Spark is a very popular, I think many of you probably already use it. What we're going to do is we're going to go into Spark, which is also set up and pointed to this data lake, and we're going to go ahead and do a little work on it. So for example, here we are in Spark. Let's just go read the data in Spark. So, and don't be alarmed, it's slow. This is one of the reasons why it would be cool to have ClickHouse. You saw how fast those ClickHouse queries were. Spark is very slow, but it gets the same data back. By the way, we can show that we have up here our Python. Let's go look at our Python data. So there we go. Python's a bit quicker. So same data. And now we have ClickHouse, but we're going to wait for a bit. What we want to do in Spark is actually do a change on this data. So let's do that. We're going to wipe out a couple of the rows, anything where the bids are less than a certain amount. So that ran. Let's go ahead and check the data that we have. There we go, 2 rows. So so that wiped them out. Let's go ahead and look at them in Python. 2 rows. So Python can see it. These guys are looking at the same data. ClickHouse can see it too. So let's go ahead and get our ClickHouse thing. Just go ahead and go directly from the iceberg table. Boom, it's got it. So this is cool. What you're saying is Spark can change it, and ClickHouse can see it. Python can see it too. One final thing. Let's go back and select the data using S3. In fact, using our previous ways that we could select it. Let's go ahead and select it using the iceberg table function. That reads the metadata. It also gets 2 rows. But what happens when we go to S3? Just select it directly from S3. And up. Once again, fail on copy paste. There we go. This is what happens when you read the S3 files. The S3 files are still out there. Iceberg keeps the data around because it has a notion of snapshots. And actually what you can do is you can ask ClickHouse to read the older version of the data, but S3 doesn't know about versions. It doesn't know which versions of the files are valid at any particular time, and so it gets the wrong answer. This is the reason why, even though it's convenient sometimes to read data directly from S3, you can't use it for Iceberg. It will give you wrong answers. So that concludes our demo. We've shown the different ways that we can access this data in ClickHouse. We've also demonstrated that other people see the same data when they change the data, ClickHouse sees it too. This sharing of data is a very, very powerful feature because it means we can now combine these things together to build much more capable systems. So let's go ahead and talk about that. We'll go ahead and conclude the demo. Let's go ahead and put that away. Just a second here. Move that out of the way and bring up our slides, and let's dig into building data lake applications with ClickHouse. So more features. One of the things that ClickHouse can do is, and by the way, Alexander, I think you're copying, handling the questions. Thank goodness, there's a bunch of great ones coming up. Keep them coming. So let's talk about some of the additional features in ClickHouse. So clustered reads on iceberg tables. It's really important when you're reading from data like S3 to be able to do the reads in parallel, not just on the vCPUs that are available to a single server, but across servers. So there is an iceberg cluster function, and it works kind of like S3 cluster. In fact, it works exactly the same way. Basically, what you do is you have a cluster name, which is a list of servers. You give it the path, and it will use the resources of all of the servers simultaneously to do reads. This is a very powerful feature. How does it do it? Well, this is actually pretty important. So you do this select, it comes in, and the server that it hits is what we call the initiator node. So that initiator node is going to read the ClickHouse metadata and find the file locations. And then what it's going to do is it's going to pass those locations out to the nodes in the cluster that actually do the reads. So it's going to make decisions up front, which files should we read and where are they located? And this is at this level, you can actually do partition pruning, which would say, recognize, hey, we're only looking for data for today, therefore we can skip all the files that aren't from today. That partition pruning, I think, just arrived in ClickHouse. So the files get parceled out to these other servers. They do their reads, and then the results get streamed back to the initiator, which gives you actually the final result set. This is a very powerful feature. because it now allows us to, and we'll talk about it a little bit more, but expanding this will give us the ability to have very, very fast reads uh, on Parquet because we can just throw a lot of compute at it and also have them each use their own network connections so that we can increase network bandwidth. Another question is what kind of optimizations are available for Iceberg Parquet reads? Well, it turns out there's a lot of them. So at the lowest level, there's been quite a bit of work recently uh, on Parquet, on just making Parquet fast. So, for example, uh, using Bloom filter indexes, which are a feature of Parquet, that's something we put in. I think it went in back in October. Min-max values. These are Parquet has a notion of blocks of data. They're called row sets or row groups, and you can see min-max. Doing partition pruning so that you don't read all the Parquet files. That's available. There is work going on to do preware, which is where you come into you're looking at Parquet, and if you don't have an available index, but you're selecting off a column, you can basically take that column as an index, scan it in advance, and then use that to select the row groups. Work on that is ongoing. Um, ClickHouse has very good caching for S3, and so you can set up a file system cache. I'll show you how to do it in a second. That works now, and your queries, as they pull from the Parquet data, can take advantage of this. What that means, of course, is if you touch the same Parquet files from the same server, the reads will be vastly faster because they'll be on local disks, so you don't have to go a long way to get them. Even better, since they're on the file system, if you read from it, they'll go into your buffer cache so that you're effectively reading from memory. There are two other kinds of caching which are necessary to make uh, Parquet reads on Iceberg fast. They're in progress. The first is to cache Iceberg metadata. So that means instead of having to go to the REST server and ask for it every single time, you just remember it. Uh, and of course, you have some strategy to make sure you don't get out of date. The second thing is to cache the Parquet metadata. Parquet has schema. It has information about row groups. This is also information that we would like to cache in the same way that ClickHouse already caches the contents of indexes, so that we don't have to go, read the index every single time when we're doing selects. That's actually work that we're doing right now and should be available soon. So what's happening here is that Parquet reads are becoming very, very capable, and we will quickly see them becoming competitive with merge tree for cold data. Not necessarily for hot data, but for cold data. So this is improving rapidly. There's already a lot there. In fact, well, here's the disk caching. So if you want to do this, this is how to set it up. It's a little bit complicated right now. You basically set up a cache. This shows you the XML to do it, to teach the ClickHouse server how to set up this cache. And then you have a couple settings to invoke the cache to use it for your queries. This, of course, can be smoothed out, and it will be over time. But this is how you can do it now, and you can see these caching effects today. Speaking of things in ClickHouse, one of the things about ClickHouse is it's actually really surprising if you begin to look around how much ClickHouse can actually do with data lakes. And part of the reason for this is ClickHouse has so many features for for accessing data in flexible ways that we can now apply those to data lakes. Here's a great example. It's very common to want to have hot data inside merge tree because it's super fast for a variety of reasons, but keep the cold data on object storage. You can actually do that with Iceberg today. Basically, what you do is let's create a local table. So this is a merge tree table, and what I'm doing is creating it using the columns from my data lake table. And then what I did, I didn't show this, but I pulled a little data off Iceberg and tweaked it. But then the next thing, so I've got some local data that's different from what's in Iceberg. Then I can create what's called a merge table. So a merge table is a specialized table engine which says, hey, here's two data. Here's a collection of tables. Just read them as if they were a single table and just union everything you get back and pass it back to me. And so I create this merge table all bids, and that points this regular expression will pick the two database, the two data lakes, and pick anything that has bids in the name. And when I do a select, I get both my hot data and my cold data back. This is a very powerful technique and something that can be used to do what you might call poor man's tiered storage. But the key thing here is you get a single SQL interface and you can see everything. You can see the stuff locally. You can see it. You can see it in. Uh, you can see the data from Iceberg. This is something we plan to leverage as we go forward, and make this much easier to use and so that you can build systems. So that I see a bunch of questions coming up. Keep them going. Thank you, Alexander. It looks like you're pretty busy there. Let's talk about building ClickHouse apps that run on data lakes. So the first thing to do is to kind of get real about what ClickHouse can do and not do. And then we'll look at the roadmap and then we'll think about, okay, here are some systems we might want to build, and here's how we could go about doing them. So what does ClickHouse have already? Well, you've seen a lot of it on this already on this presentation. We can read and write to S3 storage. I didn't show you that. Well, I did. I showed you the S3 table function, but this is very capable. We've performance tested this over the years. It's awesome. ClickHouse can read in parallel across many S3. It can also write very efficiently. This is great. As it turns out, when we read from Iceberg, we're using exactly the same code that reads from S3 because, in fact, we're just going to the S3 files and reading them. Iceberg just helps us find them. It doesn't change the actual read path. We can also read and write Parquet. That's another thing that has gotten much, much better over the last 2 years. And there's a raft of features coming that uh, will help it. We can connect to the Iceberg catalogs. That feature was added in December by Ksenia at ClickHouse Incorporated. It's a great step forward so that now these things really just look like ClickHouse tables in a database. And of course, there's all these optimizations that are coming along, which is going to make this stuff a lot better. Here's what we can't do. We can't write to Iceberg from within ClickHouse. We can't archive data from Merge3 to data lakes using tiered storage. We can't do merges. So if you write to merges are really important for large tables. You may write little blocks of data when you initially insert. You want to actually coalesce them into bigger blocks. And then finally, we have the parallel query, but a really important capability is to be able to auto scale it to come up with clustering models, for example, that can lean on the ability of things like Kubernetes to allocate large numbers of resources at will. So build them up if you have a busy time for, like, say you're building a trading system, it's during the trading day, uh, something interesting is happening. So a bunch of people are running queries. You need to be able to build up capacity at that point and then shed it as soon as the event is over. So being able to do that kind of parallel query is something that is very important to build these systems. So what do the roadmaps look like? So here's the ClickHouse roadmap. You can see it right here. There's a bunch of good stuff in there, like pre-wear support, partition pruning, uh, writing to Iceberg tables, and compaction is also out there, but it looks like it may be held back as just something that works in ClickHouse Cloud. But there's very active work here. If you go look at the PRs that are being done, what's really great is not only are there people like Ksenia putting this stuff in from ClickHouse, but there's a raft of people from different organizations that are contributing these things. This stuff is getting better fast. And that's one of the things that's really great about ClickHouse. It's such a wide community. We're also working very actively on this. So a number of, of the Parquet low-level optimizations are things that we did. We have now 2 or 3 people working on it. We have a bunch of QA people, uh, and we do builds. But here's some things we're focusing on this year. One is this flexible scaling of S3 and Parquet, or S3 and Iceberg queries. We'll have something fun to show you in the month of February about this. Um, Efficient writes to Parquet. So being able to export data out of ClickHouse and put it into Parquet is a very, very important topic. Open source compaction and transformation. So being able to, build the ability to read data and then transform it in different ways, of which compaction is a very important one, put it back into the data lakes. We'll be working on that. Um, Tiered storage. So not all of you may know this, but we did some, not all of the implementation, but some key parts of the existing tiered storage like TTL moves. We're going to be focusing on getting those to work for tiering merge tree tables to out to Iceberg data lakes. And then finally, we are planning to and working on this right now to have the Iceberg catalog service be hosted in Altinity.cloud. So that's in our own uh, cloud. So this is something we're working on. You'll see these features trickling out over the course of this year. Um, with this roadmap in mind, it's now we can think about, hey, what can we really do with this? And you as a designer looking forward, you're building a system now. Uh, you don't, there's features that are, of course, that are coming. How can you plan to build systems that take advantage of what's there already, but also the stuff that's coming uh, uh, down the you know sort of down the pike. And one of the things I I was talking with people before setting this talk, like what kind of applications are you building and what would you like to see? And a couple people mentioned medallion architectures, which are uh, kind of a cool notion of that are often commonly used in data lakes. It's it's sort of a way of dealing with data that's coming in from sources. It may be raw, it may be dirty. So you have a notion of a pool of data that's you call it bronze. That's just the raw data dumps. If they're coming from like trading data, for example, you may have to do some cleanup on it before you can use it, and so then you get it filtered and clean, and then you finally build your aggregates, which allow people to get fast answers of it. So you can think of that as your materialized views in ClickHouse parlance. Can you build this system right now in ClickHouse? Well, the answer is yeah, kind of not all the parts are there. So what you can do, what you're going to have to do is combine with other types of applications that can also see the data lake. So for example, Kafka can be combined with the tabular folks did a connector for Kafka that will dump it into Iceberg. So you can connect those two things up, and that can allow you to dump the data uh, into Iceberg. Filtering and cleaning involves both reading and writing, which ClickHouse can't do the writing part yet. So you'd use Spark for that stage right here. But then it gets interesting. At that point, once it's cleaned up, that source data, ClickHouse can actually read it. Moreover, you could pull that data down and put it into you could read it and you could build your own aggregates. You won't have materialized views yet. That's something that will be coming in ClickHouse, but you'll be able to create your own sort of hand created materialized views and by just having jobs that select it. So you can actually build this, a chunk of this, and as time goes on, what we expect is that between bronze and silver, for example, you will be able to drop Spark and put ClickHouse in and have it uh, uh, basically do that as well. And so what you'll get is you'll basically have the source data out, cleaned up source data out on Iceberg, the aggregates stored inside ClickHouse itself because that makes them really fast. That's actually a really capable system and something that opens up some very interesting new horizons for using ClickHouse's speed, but also taking advantage of shared data that everybody else can see. So this is something that you can start to design now and then evolve it over time. In fact, it's useful here to think about like what are the real options for these pieces. So right now, you could build a system like the medallion architecture. Take that as an example. There's a nice article on the ClickHouse blog that shows how to build these, but it's basically ClickHouse only. So you're going to do them inside merge tree and have the data uh, uh, sort of move from place to place. So this is integrated. it's fast, but the data is not shared. Moreover, um, you could have, if you have very large data sets where other people are putting the data in, it's not going to work because you don't have the sharing. You could kind of cobble something together on S3, and I actually had somebody ask me about this. Yes, you can get fast read and write. Sharing is possible, but it has to be done very carefully, as we saw, because S3 table functions don't know what they're looking at. You can get wrong answers. So that integration of how you use that S3 data effectively is difficult to do. In this case, you'd be building a system that perhaps doesn't even use Iceberg. It could at most have like Hive formatting or something like that. But you're basically not going to have the metadata. So the final solution, which is available now, is or emerging now, is to combine it with the data lake. So you can have local data on Merge-Tree, shared data in Iceberg. It's integrated. That's, we can actually see these tables, treat them as ClickHouse data tables that look like they're in a database. The sharing, of course, is excellent, as you saw from these demos. The reads are fast. They're going to get a lot faster over the course of the next few months. And of course, the integration with ClickHouse is really great, so you don't have to worry about paths. And it's it's not so much that you don't have to worry about it. If you're the DBA, you understand where the storage is. It's your users that don't have to worry about it. So that makes life better for them. So these are your options today. What we'll see is that this ClickHouse plus Data Lake option is going to open up over the next year or so, and we're going to also have writes. And at that point, it gets pretty interesting. So one final interesting thing that should be on your radar is managed data lakes. This is what we saw with Kubernetes a few years ago. Was when it first emerged in clouds, everybody ran it themselves. So using things like kops. But pretty quickly, the service providers or the cloud providers realized that managed Kubernetes was a really great moneymaker because it helps people consume a lot of compute and storage and network. So they built things like EKS, which basically you can run a Kubernetes cluster for about 70 bucks a month on Amazon, and everything else is just the expense of running the VMs that actually take care of the Kubernetes workload. And so, of course, that's become pervasive. It's now relatively rare in our experience for people running on Amazon or Google, for example, to run Kubernetes themselves. They just use the hosted Kubernetes that's available from the cloud provider. Same thing is now happening with data lakes. Catalogs are an obvious thing to manage, and this is developing very quickly, in part because some of the catalogs already existed, like Amazon Glue or Oz Glue. But Databricks is building a hosted catalog based on Unity. Snowflake has Polaris. So this is something that rather than run it yourself, uh, your cloud provider can do it. And in fact, as you saw on our roadmap, we're planning to do that, and we'll be able to deploy this very shortly in Alteneity.cloud. The other thing, and this is, I think, the more profound thing, is that the actual storage itself, the whole data lake, will be managed. And there's a number of providers here. Databricks, of course, they sort of invented the whole notion of the data lakehouse. So they're very focused on managing this for you. OneHouse is another, a new provider. They basically uh, set up data lakes that can actually look like they implement multiple table formats, like Delta Lake versus Iceberg. You have your data in one place, and they can show it to you different ways. I think the most interesting thing for my money is the S3 table buckets. This is a new kind of S3 bucket, which is specifically designed to hold Iceberg data. And it has a couple of important optimizations. One, it knows about Iceberg metadata and won't let you use the bucket in ways that violate the rules of Iceberg. So for example, you can't just go out and list data, list files and run them. And it and then it has it has the actual uh, data it takes care of the data, in the bucket. Another important thing is it has performance optimizations for the type of access patterns, like a lot of API calls that you typically get with Iceberg. So this is a really interesting development. We'll see probably every single cloud provider do something similar. So that gets us to the end. This is, thank goodness that Alexander's been answering questions because we have a lot of them. Just a summary, how do data lakes affect your ClickHouse stack? That was the point of this talk. Well, first of all, there is an emerging solution now for a single copy of data on cheap storage. People have talked about data lakes before, like 10 years ago when Hadoop was big. It was kind of a mess. This stuff actually works. We've seen enough applications built on it, and there's enough momentum behind it that it looks like it's now becoming viable. Iceberg and Parquet look really solid. Uh, it doesn't really matter whether they're the best choices. It's just a lot of people are using them, and it's kind of a network effect. Uh, Databricks, for example, is betting big on Iceberg. That's why they bought Tabular, and so is Snowflake. Um, Iceberg and Parquet are going to be competitive, I think, over the course of this year for reads on shared cold data. So, and by competitive, I mean competitive against merge tree, that they have enough advantages. There's some things that they don't do so well, but they have enough advantages. This is something you're going to want to use for cold data. Uh, just keep it outside ClickHouse and on your data lake. Let everybody else look at it, and it's going to work. The writes and tiered storage will emerge over the course of this year. Another thing about ClickHouse is there's just like way more in there than you think. As you start to look at the parts, the ClickHouse stuff is being fit in a way that integrates really well with the existing, uh, you know, uh, with the existing models. So things like the way that we use threads to, like max insert threads, those options continue to work exactly as they do in the rest of ClickHouse. They will work when we're talking to data lakes. So you can combine things. We talked about managed data lakes and storage. Final thing, you're going to need to stay up to date. I was actually, for a while when I was doing these demos, was actually building ClickHouse just to make sure I knew what was in it. But you'll want to get the latest builds because they have these options. We are going to, I think some of you know Alteinity's stable builds. We're going to be introducing a new type of build called an edge build that allows you to catch stuff that's much, much closer to the head. In fact, it is based on the head, and you'll be able to get these features faster, or you can use the official releases from ClickHouse Incorporated. You'll want to be on the latest ones so that you have these great features. There's a number of references here. I think a big thing on data lakes, and one of the reasons for this talk is it's hard to put it all together. This talk is partly designed to do that. We'll be introducing blogs, so check out the Alteinity blog to cover this material. If you want the background, I highly recommend the CIDR 2021 paper by the Databricks folks. This is really great and kind of laid out the principles of this architecture. So, this is a really good reference, as it's now 5 years since it was, or 4 years since it was written, but really kind of sort of outlined this architecture, and I think you'll find it very useful. With that, we're done. We'll stick around for a few minutes and answer a few more questions. Thank you so much for the questions and your interest. You can contact us if you want to talk about this more. Come join our Slack. It's really easy. You just go to our website and press the Slack button, and it pops you into. It'll get you right in. You can contact us. We're going to be at FOSDEM as well as State of Open. Those are in Brussels and London in early February. If you're attending those conferences, connect with us. Let's talk. This is really interesting stuff. We're here to, we can help you. And of course, we do if you just need ClickHouse hosted, well, we're the right people to talk to about that as well. So with that, Alexander, any interesting questions you want to talk about? I know that you were answering a bunch in the background.
There were a lot of interesting questions about tiered storage, about applicability of data lake for different scenarios as well. So I hope that these questions that were answered will be available as a part of recording. So
yeah, they should be.
Get that.
Yeah. Yeah, we'll have that. And by the way, for those of you, I connected to a number of you on LinkedIn. Thank you so much for the suggestions and the things that you wanted to hear about. Continue we can continue those conversations on LinkedIn. I also recommend coming and joining the Slack. You know, these are topics we're working on day in and day out, and we're really happy to share the information. Uh, uh, this is I would say one thing in summary, this is a technology shift like Kubernetes. The Kubernetes was something that we got on about 6 years ago now. And it was pretty new and it didn't work too great, but it's now pervasive for building SaaS platforms because it allows you to build pools of compute and storage, and it's portable. So data lakes have been proven that there's still a lot of loose ends, and you'll find that you have to pick your way through, but this is an emerging technology and it's going to be really critical for building large systems. So I think it's important to get involved now. Uh, and this is something that we're interested in, and we're here to help people do that. So we welcome your questions, and if there are ways that we can help you build these systems, come talk to us. That's our business. So with that, I think we will conclude this. Please join our Slack. Come check us out. Talk to me on LinkedIn. And good luck building these systems. It's a really exciting time to be designing large systems, and I wish you every success. So thanks, and we will see you soon.
Thank you, Robert.